Yes, if you can quickly run the code so we explained so far. For example, the first one, as we said before, is we put it in cell one in order to give us the project root, which will be very useful in our case. And then once we've done that bit, this is the explanation of what the data is doing. We explained it before, and this is we are also running you are bringing the policies, which I'm going to explain now, and then the utilities, which also I'm going to explain first now. And then we need to put like the path, all the passes which we need, so that when we load the data, we can give the pass where to put, where to read the data from. So in here, we are reading the data from this path, which we have like identified or created it before, not created it like, but we just say which path we are going to use. And then in this specific path, the customer silver dataset lives, and then we are going to read the CSV file from it, and then also the order file, CSV file as well. And then to make sure that it had been loaded, we need to see the head, yeah, and sometimes also we can see. We can see, as you can see here, for example, if you run this bit, we can see which one we have loaded. Yeah. So now let me just give you like an overview and what is happening within the utility. As we said before, the utility is like the one which we are going to give a user access to the storage. So they need to go to the storage, either read from it or write for it. So we are emulating that kind of exercise using this utility. So the utility will have a couple of skill set which you need to know if you have used Python before. There is like read write for a table data frame as it is, and then there is also JSON loading and saving as well. What we need to do is like we need to make sure that we need to create a directory for the work we are doing. Yeah. So if this doesn't exist, if we supply, for example, a path where the CSV file or Purview file is sitting, then we need to. If they don't exist, we need to create those paths. Yeah. So that's the one creating a folder, and also reading and writing, giving access to those ones. Yeah. And then specific different kind of file format, that is like CSV, Purview file. That's what we are going through. Even here we have encoding of UTF-8 for the text file. So the model, what it's doing is the first part is, as I said before, this is the folder structure, the folder. Overall, what it's doing is like it creates directories, as we'll see shortly, and then read tabular data, write tabular data, and load metadata in JSON format, and then persist metadata, which saves the JSON as well. So this is like interaction with the file system. So governance is enforced not only by what you access, but how you access it as well. Yeah. So as a design principle in here, what you are seeing here is explicit file format only. So we just not any file. We are saying either CSV file or Purview file. So that is one design principle we are using: explicit file format, predictable behavior, and then so defensive failure on unsupported operation. No silent assumptions. Yeah. So everything is clear. So that is the design principle we are using. And now we are going to see how we are using them. For example, on the first function is like the purpose of the first function is to guarantee that directory exists before use. So this part, this side first is it guarantees that directory exists before use. By the way, we have done through we went through this future annotation before. That's why I'm not just talking about it now. Yeah. So and then you have why do you matter this? Why do you need to make sure that the directory exists before use? This is like to prevent runtime errors and remove ad hoc directory creation, because don't forget we are doing a policy and security side for it. So we make sure that there is nothing is being created, the one we don't know. Make data path predictable as well. So we give a predictable data path and then we create those ones. Yeah. So in terms of governance, what it means is like storage location are intentional. Like pipeline do not create shadow folders. Yeah, that's the key part here. Directory creation is explicit and traceable. It's not like implicit. You don't assume that it's being created. You explicitly say we are going to create this specific directory. And the second function is read table, as you can see. And then the purpose of this one is to provide a single governed entry point for reading tabular data. So you can only read it from this function, and then we are putting also two supported formats like CSV and ParQ, as I said before. So it prevents uncontrolled file access and ensures consistent ingestion behavior and makes allowed format explicit. So failure behavior, unsupported formats raise an error immediately. This is intentional governance issue. So that is what you can see here. If it's not supported file type, if you provide, for example, Excel sheet, it will tell you that's not allowed here because it's not supported in here. Yeah. So that's again, this is the governance side of the so answer the governance side is this is intentional governance code, and if we provide the unsupported file system, it will fail. Yeah, it fails. So the right table function is also its purpose is a controlled way to persist tabular output. The way it behavior is ensure parent directories exist and enforce explicit file format, prevented accidental writes to unsupported types. Yeah. So outputs are predictable now, storage layouts are standardized, and downstream consumption is safer. The load JSON file, the purpose is to load structured metadata from disk. Yeah. Typical uses is like audit logs, policy snapshots, configuration, model metadata as well. Yeah. So that's and the government meaning is metadata is first class. Yeah, and then policies and evidence are readable and inspectable. And the save JSON is persistent structured metadata in a human readable format and ensures the directory exists. Writes indented JSON for audit purposes, and the government meaning here is decision leave evidence, and also evidence is readable, accountability is preserved. Yeah. So the governed meaning for the whole lot of the control is the module enforces a critical principle. Data pipeline should not improvise how they read or write data. So by funneling I/O through a controlled utility, you can gain consistency, predictability, auditability, and reduce attack surface. So why is this important for AI? Because this is the one we are doing, AI readiness. So AI system amplify mistakes. Don't forget that. So if data and metadata I/O are not controlled, training data becomes untraceable, and audit trails break, compliance claims fail. Yeah. So these utilities create a minimal but sufficient control surface for safe AI operations. So that is the utility in practice. So the utility function, the one we are doing there, is only sanction doorway between governance logic and the file system. So you have the files, the governance logic. So in a nutshell, our notebook requests access, for example, the notebook requests access, and then the policy, which we are going to look now, policy decide the access, who have access, yeah, and then the utility execute safely. Yeah, that's the key part. So this is how it is structured. Yeah. So you have the notebook, the governance policy, which we are going to look just now, and then the controlled I/O, which is we have explained in details seconds ago, and then you have the file system, the storage, which we call the where the silver data set sits, yeah, for consumer or customer, for order, and so on and so forth, yeah. So now we just let us look at the second side of the story. This is the I/O, as we said before. We have just mentioned this side, the util, yeah. Um, so for example, if you want to read, yeah, in the notebook, what we do is like we have from util, we import read table. This is the table, and then what you do is like the read table, we give it like the path, and we are saying read this Parquet file from that path. So this is we are providing the read. So what happens at runtime is the path is passed to the read table, this path, yeah. And then the file extension is inspected, this, yeah, and then only approved format are allowed. So pandas loads the data, unsupported format fail immediately. So the government meaning is no ad hoc file access, no format drift. Entry to the pipeline is controlled. Now, enforcing the access policy before use. For example, we have this the access policy. Probably we'll try to explain it later on. So we have this access policy. The access policy has two. We are importing to user context and apply row level policy. So in here, what you are doing is like, for example, we are creating the user and the role and the allowed departments. And then what you are going to do is like we are going to read table, as you can see here. This is before. And then we are going to do the security. We are going to provide the CTX variable, which have this user and role and department. So that will be the secured access for the customer data. So we are reading here, and then we are giving access through this one, yeah. So read table does not decide access, yeah, and then apply row level policy does, yeah. So that's the one which is going to do the access control. So the responsibilities are deliberated separated, yeah. So read does not give you access. The apply row level policy gives you the access, yeah, in this case. Now, also the writing controlled output, like from the util, we import the write table. So the customer secure, this one, which this customer secure, and then this is the write. We are writing this one, yeah, the customer secure, and then we are writing it in this data product side of it, yeah. So directory exists. For example, output format is explicit, no silent side effect, predictable storage layout. In the governance meaning here is output are reproducible and safe for downstream consumption. Now the audit side, which is JSON, so we import the util that saves JSON, and then we have the timestamp, of course, because we are going to put timestamp there. So for the audit event, we are going to the user from the ctx.user, as you can see here. This user will be Ahmed here. And then you have the role, again from the same thing, which is the role here, dot role, the ctx.role, and then allow department. the data set is going to be customer silver, and the timestamp is this one. So, and then what you do is like you need to save JSON. This is audit event, and you put it in audit log, and you put it in here in this side to it. So JSON is human readable and machine parsable as well. So that's why we are using JSON here. Auditor friendly and diff friendly in Git as well. This is evidence, not debug output. So loading, configuration, or policy snapshot. So what we can do is like from util, you can load JSON. So policy config, load JSON. It's if the department the JSON, this is the config file, sits there. So policies are inspectable. Configuration change without notebook edits. So the governance logic remains stable. The most important rule here is if code touch the file system directly, governance is already broken. So we are not touching the file system. So that is why no pd.read CSV in notebook, no df to Parquet scattered around, no ad hoc open files here. Everything goes through the util functionality. That's very important one. This is like this is how we need to control our system here. So especially for the production environment. So that's the key part. Production, you need to be careful who should have access, especially our file system should be controlled. So we shouldn't put in our notebook, for example, write, read, and so on and so forth in a notebook randomly. So we created this utility to control the I/O to our system. So in AI systems, yeah. So to train, to retrain, to fine tune, replay, explain without controlled I/O, training sets becomes untraceable, as we said before. Audit trials break, and then compliance collapses. Yeah. So controlled utilities make AI traceable, repeatable, defensible as well. So we do not let notebook touch storage directly. That's not a technical choice, it is a governed decision. So can you see here, the notebook does not touch directly, it is the, and then we touch the file system via another utility. So when AI decisions are questioned, this is the layer that proves what data was seen and when and under which rules. Yeah. So ownership registry is another one, another layer. So governance begins with accountability. Always in AI, the accountability is like a pillar, a very important principle, accountability. So we need to have like accountability is a key part when you build our AI systems. So within the governance utility, what you will do is like we'll have like a data set which is owned. We need to say who owned the data set. Could be the owner or the steward of the data set, and there's a sensitivity level allowed rules as well. So first we need to trust the data. That's the key part, because we put it we have done that bit. We went through the ingestion process, the bronze, and we do data quality and validation. So there is a trust process, and then should be after that the control. Yeah, silver data is the first layer exposed to consumers. Yeah, so the raw data, as we said before, we don't expose it to consumers. So the governance pipeline framing. So you have on the pipeline, the governance side, we have the curated data, the user context, policy enforcement, authorized view, and then audit log. So let us see the ownership registry, which is what we are creating, the data frame. The data set is customer silver. The owner is like this is the owner, the steward, we are saying here is the owner is a finance steward, and here's the data steward. Yeah. So, and then sensitivity is like one is confidential, and second is internal. So the allowed roles in here, we have two roles we created already, the steward and then the analyst. For the order, for example, allowed is steward, analyst, and viewer. So when you run this code, it gives you have two data set. Yeah, the you have these two, the ownership registry. This is the registry. It has two data set and two different owners and also sensitivity and who is allowed into that one. Yeah. So in here this is explanation for what is happening when we are doing this bit, this how it is created or the format. So the ownership, we are creating like a data set called ownership registry, which is a data frame. And then we are looking at this one. And when you look at it, for each data set, we are saying who owns it and how sensitive it is and which role are allowed to access it. Yeah. This is not metadata for convenience. This is governance metadata. So the reason why we do is no one AI and analytic system fails when no one owns the data. Sensitivity is undocumented, and access rules are implicit. So this registry answers three non-negotiable questions. Yeah. So these three: who is accountable? How sensitive is the data? Who is allowed to use it? If you cannot answer this, you cannot govern your AI. So you are not ready. You cannot if you cannot answer this question about your data. So the data set is the name of the data you are looking at, you want to govern, because policy attached to data set and not to the file path. Yeah. So data set are critical, they are attached to the policies. Names are stable even if storage location change. Yeah. And the owner, the accountable person or role for the data set, this is a steward, a business owner, or a governance authority. It should be one of them. Yeah. And governance meaning there is always a human responsible. There should always be a human responsible for the data set. And issue have a clear escalation path. That's the key part. So if there is a troubleshooting, if there is a problem, if people want to raise issues, then they need to have like escalation path. For example, it might be like a steward, and if it's beyond the stewards, could be the business owner, yeah, or the governance authority at the end of it. So there should be like escalation process for the data. So ownership is explicit, not tribal knowledge, yeah. So we need to explicitly say who owns a specific data set, yeah. And the sensitivity is the classification level of the data set. So example could be public, internal, confidential, and restricted. So drive is policy enforcement. So if you want to enforce a policy, you need to understand which is which. Whether it is public, you don't need to enforce any policy. But if it is internal, confidential, or restricted, we need to enforce certain kind of rules onto that data set. So informs AI usage constraints as well as supports regulatory compliance. So for example, if you are going to comply with rules, regulatory rules, then we need to have this kind of sensitivity label. So sensitivity label is not optional; it is a foundational one. So allowed rules, it is a comma separate list of roles allowed to access the data set. So why the roles matter? Access is role based, not individual based. Yeah. So roles scale as well. Roles are auditable. They map directly to. So the roles they map directly to RBAC, role based access control, and also attribute based access control. Attribute based control is like the one we were talking about, whether if a person, not a role, but based on his department, for example, he can have access to certain data. So in the registry, the table is not passive documentation, it's consulted at runtime. The table we created here at runtime, what we can do is like we can bring the metadata, for example, and then we query it, and then we take the first part of it, and then if there is on the first, we split the allowed, for example, here the allowed rules. So if not in here, not on this list, for example, then it can say permission error, access denied. Yeah. So that's how you use it. So you have this registry, and then the roles which exist there, you check them here. If you check the roles within this uh, user context, yeah. So if that one that is not exist on the registry here, the role which is coming from this, then it will have a permission error. That the register becomes a policy input, not a spreadsheet. Yeah. So the registry enforces a core principle. So every dataset must have an owner, a sensitivity classification, and explicit access rules. Without this, policy cannot be enforced, accountability collapses, and AI usage becomes legally indefensible. So why this matters for AI systems is AI systems amplify ambiguity. This is very important. If ownership is unclear, data misuse goes undetected, accountability is lost, trust evaporates immediately. So this registry creates clear accountability, reviewable access rules, and a defensive governance posture. So we can see here, you can say from here, for example, this is how for example, who can access it. You have a data set here, a user context, and then in the ownership, we say we did the one we have done. So if it is there, it's allowed. If not, it's not allowed. Yeah. So on the audit as well, this is again to write the in the audit and also explicit users and rules here. For example, this is a user coming. It could be from Active Directory, or in this case, you can do it also explicitly here. What you are doing is like in the user context, we are given a user. We are creating this is the user and this is a role and allowed department. Yeah. So this is another one and this is another one. So we create, for example, this one within our here, and then what happens is like when we want to give access. So this is what is going to happen. So the access, we will have the data set. We pass the data set, and then we pass the user context. Yeah, this is being created, and then we pass this one, and then this one will tell you whether allowed or not. So if the user, which is here, for example, Alice or Bob, is admission here. So he's from admission, and then once you go to the registry, and then when you split the allowed roles, if admission is not there, so it will raise an error. If it is there, then it will tell you yes, you are allowed, and you can do your access. Yeah. So we can see in a very precise way here. For example, the access here, what it does is like look up a data set in the ownership, the one I was just describing just now, and decide whether the user, the role, is permitted to access. And the audit, what it does is appends any audit event to CSV log, so you can prove that who requests access, when the request happened, what data set was involved with, what decision was made. And the users create sample user context to simulate different roles and entitlements. Yeah, that's, as I said before, you can create it in a code here, or if you have Active Intra ID, you can create that user and that role, and then based on that you can also work it that way. But the easiest one is like to have a simulation of Enter ID, and you create a user, and then you test the access using that side to it. So, for example, in here, the ownership registry, you have the data set and the first one. So, filters the register down to the row of the given data set, takes the first match. Yeah. So, the first match of the data set. So, access decisions are anchored to registered metadata. access is not decided by notebook or author. Yeah. If the dataset is not present, this will raise an error. In production, it normally fails safely with an explicit unknown dataset deny kind of thing. Yeah. So the allowed roles, as you can see here, reduce the comma separated roles, split them into a list, the allowed ones, and then strip through white space for clean comparison. So allowed roles are explicit and reviewable. Roles lists are easy to audit and change control. So it will now returns true if the user's role is permitted, returns false otherwise. So the governance meaning is this is the simplest form of RBAC. The decision is deterministic and testable. So audit as an event is like a data frame, wraps the event dictionary into a single row data frame. Consistent schema for login, easier aggregation and reporting user. So if the directory exists, if audit file already exists, loads it, appends the new event, as you can see here, if it exists. Yeah. If it doesn't exist, the file, the path, it will create it. Yeah. So otherwise, start a new log file. It exists, append on this CSV file at the end. Yeah. So creates a durable record for access decisions, support traceability and compliance operations for high volume. This pattern should be replaced with an append only store. I mean, this is again an example, a very simple one. It's not like complicated or so. I just am trying to explain what is happening. But the concept is very simple, but if you understand how it works, then you can make it bigger in your system, especially if you work in Databricks or Fabric or Snowflake. You can easily rewrite those ones in a very useful way. You don't need all this, the one I'm trying to do, because you will have a system like Active Directory, you'll have a grouping over there, you have like also manage the identity, you might have, you might use like vaults, to secure security and so on. So you will have a different way of doing it, but the concept I'm just trying to explain here, the concept of governance and how you need to prepare your data and how to make sure that your organization is AI ready, and this side is AI readiness on the governance and security side. So just we are trying to understand the governance and security side to make sure that when we do the assessment, it will make sense at all, a lot of sense when you do the assessment. Yeah. So this is like when you do like the mapping, it just decision control and the proof of control. Proof of control is the audit we saw before. So you don't have a silent access, shadow analytics, or untraceable AI training inputs. Yeah. So I think the there is also another data set where we can do like the access decision loop. Yeah. So what we do is like the document explains how the access decision loop enforces control and governs by combining dataset ownership rules, role-based access checks, role-level access security, and audit logging. Yeah. So you have this is a dataset. So for users which we created before, remember here, if they don't this access dataset, if they're there, deny them. If they are not there, yeah, and then put on the system the time stamp, the role, the user, the role, and the data set, and also action is denied. So this is a data set here, and continue. And then for the scope will be the apply row level policy. Yeah, and this is again for the customer. The data set is the customer and the department. So it's allowed if allowed the user if it is on this list of the user allow, yeah, and then if the department is part of in the allow department list, then you will have an allow on you in the audit system. You put an it's allowed, and you put also the user, the role, the timestamp, and the scope of the allowed as well. Yeah, so this is the deny and allowed within the when we audit our work, who is allowed, who's not allowed. So for each user, check whether they are allowed to access the dataset at all. If not allowed, deny access, log the denial. If allowed, apply row level access security, return only authorized rows. Yeah, this is the key part, authorized rows, and then log the successful access. Nothing here is implicit. Every decision is explicit. Every decision leaves evidence. Yeah, so that's the key part here. So if you look at it, for example, what you are doing, select the data set, and then this is the governance anchor, policy attached to data set, as you said before, not files, notebooks, or analytics. Yeah, so always the policy is attached to a data set. So you can iterate for the users, for you in users. So each context represents an identity, a role, or allowed scope. This simulates real-world multi-user access, and then the role-based access check is if not can access. This is the role-based access check we are using. Yeah, this can access. We look at it, how it works. It takes two arguments: the data set as well as the user. So that's the access control. So the ownership registry is consulted. Yeah, and then the user's role is checked against allowed roles. So the governance meaning this is coerced grained access control. Users are blocked before seeing any data. So the handle access denial. So print deny. This is of course print screen cannot access the data set, the information which is given, and we put them into the audit. Denial are logged. Failed access attempts are auditable. Suspicious pattern can be detected. Yeah. So applied row level security. This is again there is a script which I have written about applied row level security, and then you call that script using the customer, the dataset, the user, and the department, and the dataset is filtered by allowed department. So it is like a group by. So for example, you have select everything from a table, for example, HR table, employee table, for example, grouped by, and then by the where. So not grouped by here, but the key part here is like the where clause. So what you do is like select all the employee data, for example, where department is HR. So what happens is like only HR data set will be filtered, and the user can only have those data sets if he or she belongs to that group. So confirm authorized access. Again, you can print what had happened here, visibility into what was shared, immediate feedback for demos, and debugging as well. Yeah. So if it is successful as well, we went through that one as well. So this proves which data was accessed, capture scope and volume, supports compliance review. Yeah. So what we are doing here is like explicit access rules, deterministic enforcement, least privileged data exposure, and auditable evidence. So why does it matter for AI? Without this loop, training data cannot be proven, access violation go unnoticed, and accountability disappears.